Hi everyone. I'm with Prakash. Right now I'm doing PhD uh, from IT Guwahati, and uh, we did, we tried to evaluate the performance of precipitation. So this topic is quite different from urban heat island and all. So I belong to hydrology background. So let us have discussion on that. So the major issue what we face is urbanization, and according to UN report, like around 68% of the world population is going to shift to urban, and not only urban heat is affecting people, even people are getting affected because of flooding, and precipitation is the major input, uh, being a hydrologist, like for flood estimation and forecasting. So if you will see in terms of LULC, now the percentage of urban population growth predicted will be around 3.5 million kilometers squared, and the land cover is again expanding. So this is the one major thing. And if you see in terms of life loss and in terms of um, financial loss, it's a huge loss. From 1961 to 2020, nearly 10,000 cases were reported, and if you see like 1800 USD uh, per second they are losing, and on an average the total report death is around 23,000 per year for past 6 decades. And according to this is according to international data disaster database. And now, according to World Bank report, if you see that because of change in climate, there is change in monsoon, urban Indian monsoon, and what happened, like the thing what they predicted in will happen in 100 years is going to happen in 10 years, and that is changing the frequency of drought and flooding in large part of India. And in India's northwest coast to the southeast coast region could see higher than average rainfall. So this is the major concern, to predict the rainfall, and we cannot take. We have to take the instant data, like 2 days back data, to forecast. So what we found out, like using WRF, we can downscale the data as a dynamical downscaling model it is, and uh, it takes all land, graded data. So here we give input as UDAPT, LCG, and other LCG develop, and try to check how it is uh, showing the result in terms of precipitation. So now, as we all know, like WRF take building effect parameterization and building energy model as a couple, as can be coupled to that, and we by incorporating LCZ to WRF, we found out, like even in many parts of Europe and India, even in Madrid, the precipitation forecast has increased, and the error got reduced in that. So our study is to compare the performance of that generated LCZ and is generated European Space Agency generated LULC. So, uh, so this is the study area we try to consider. This is Guwahati. It's a major uh, part of northeast, and the area is 350 kilometers square. Actually, that's mistake, and the population is growing over here, like at a rate of 1.8%. So what happened over here? You can see there is a Brahmaputra flowing over here, and there is a huge terrain. It's a like complex terrain over here where like elevation ranges from 629 to 37.47 meters. So we try to simulate and predict the precipitation over here. So this is the domain we considered because during monsoon, most of the uh, water taken by the wind is from Bay of Bengal, and here there is Himalaya range. So this is the domain where we are trying to consider. So okay, so this is the LCZ developed by UDAPT, and this is a generated LULC. So here there is classes, as we all have discussed a lot. So and here we have only two classes, whether there is built-up and non-built-up. So based on that, we try to compare the result, and this is the since we are trying to develop for many part of India, urban part of India. So what we try to do is like automate all those things, and we change the LULC over here of WUDAPT and LCZ, and this is the first phase of work. So later on, we'll be working for other part of India, and we'll be checking that. So, and the major issue what we face is availability of data. So you can see like there is no data, station data. There is only one station data available in that huge area of city. So and in 2018, it was available, and 17, 19, 20, there is no station IMD station data available. So what we tried to check with all other global data available, and here we found out like MSWP data is a bit close to station data, so we tried to compare the result with uh, MSWP data, and this is the result what we got. This is the MSWP data, and this is UDAP generated uh, precipitation, and this is a LULC generated precipitation rainfall data. So we try to compare only two events right now, and we'll be checking for further events. So we found out like the error is around in ESA is around 17 to 100% higher in ESA compared to UDAPT in terms of MB, and if we check probability of detection at FP, there also we found like UDAPT provides us with more accurate land use land, as the land use land cover is classified accordingly. Uh, so, so in conclusion, what we are trying to say, like we need to classify accordingly LCZ to understand the dynamics of urban, and at the same time what we are trying to do is we are trying to couple that WRF with WRF hydro to understand how flood is going to get affected, not only precipitation, so that we can give at least 72 hours before warning to the local person. So this is our next work. So thank you.
Do you have any questions for Ben? Please say.
It's a really interesting study. I was wondering if you were thinking about looking at other land use land cover products, because there are probably like 15 of them right now.
Yeah, now I came to know a lot, so definitely I will be. That's why I have automated all those things. So I will be checking with other land use land cover.
Because
as well.
just like a
Yeah.
comment, because there are so many other constraints in the model, I think it's very difficult to say whether it's the land use land cover data set which is causing the better performance versus all the other constraints. So
Yeah.
it would be good to check those.
Yeah, and also we are planning to go for hybrid, as they, as I have referred them in your research paper as well. So making it data driven and dynamic driven will be a better way, I guess.
Yeah, I was going to ask a similar question. How do you separate the the variability, because rainfall is a very chaotic phenomena. So small changes in land use may lead to quite different rainfall outcomes. So when you think about undertaking an ensemble approach of multiple simulations of the same storm systems to try and separate that chaotic variability from or random variability from the change in land use as well.
Yeah, definitely we are gonna do on that as well. Changing that, like they have future plan. Like suppose they are going to make this, they have master plan for 25 years. So that one also I will be coupling in that and checking like whether that is affecting or not. Suppose any city has 25 year next 25-year plan. Like suppose they are going to construct these many buildings, and if I can get the LC, I can generate LCZ map and coupling to WR, we can say like if you will do that many construction, maybe uh, that there will be change in precipitation and also that one as well. Okay, thank you so much.
We still have time for one more if anyone would like to ask a question. If not, let's thank you. Can I call up